Hi. I'm really excited to be here today to talk to you about the critical aspects of modern application development, securing Kubernetes deployment. So as you can see from the title, we'll be diving into how to leverage two powerful tools from HashiCorp, Vault and Consul, to enhance the security posture of your Kubernetes environment. Kubernetes has become the de facto standard of container orchestration, but with its power comes complexities and security is paramount. We need to ensure that our applications running in Kubernetes are protected and that sensitive data is handled responsibly. In this session, we'll explore the challenges of securing Kubernetes and how Vault and Consul can help address these challenges. We'll cover topics like secret management, service discovery, network security policies. We'll also look into practical examples of how to integrate these tools into Kubernetes workflow. I hope you're as excited as I am. Let's strap in and let's go. My name is Damilola Afolabi. I am a senior software engineer at Volvo International. Day to day, I build software, and when I'm not building software, I'm listening to classical music or deploying or automating the deployment of infrastructure. So, all right, let's take a quick look at what we'll be covering in today's session. This agenda is designed to give you a clear roadmap of the journey through security Kubernetes with Vault and Consul. First, we'll set the stage by discussing the security challenges inherent to Kubernetes environment. It's crucial to understand the specific risks we're addressing before diving into the solutions. Next, we'll introduce the core of our solution, which is HashiCorp Vault and Consul. We'll explain how these tools work together to provide a comprehensive security framework for Kubernetes. Then we'll take a closer look at each individual tool. We'll start with HashiCorp Vault, exploring the key features, how it helps manage, security, and protect sensitive data. Following that, we'll delve into HashiCorp Consul, focusing on its role in service discovery and network security within Kubernetes. Then we'll discuss how Vault and Consul integrates into your Kubernetes deployment. We'll discuss practical examples and best practices to get you started. Continuing with the agenda, after we've explored the core concepts of Vault and Consul, we'll move to a very important section, which is the lesson learned from real-world implementations. Here we'll share practical insights and best practices gleaned from actual deployments of Vault and Consul in Kubernetes environment. This will give you a sense of the challenges we might encounter and how to overcome them. Then we'll wrap up by summarizing the key takeaways and highlight the benefits of securing Kubernetes with Vault and Consul. So finally, for those who would like to delve deeper into the subject matter, today I was intended to do a live demo, but sadly I can't. So I'll be sharing a link to a GitHub gist, including all the code required to set up and run Consul and Vault with Kubernetes, set up a demo environment for testing purposes. So let's dive into the critical security challenges we face in Kubernetes environment. Kubernetes, while revolutionized, So Kubernetes, while evolving the application deployment, brings unique security complexities. It's not just about securing the infrastructure, it's about protecting the application and the intercommunication between application. If you know Kubernetes, you understand that it's an architecture of microservices, multiple microservices communicating together. So it's not just securing a single pod, it's also securing the communication between these pods. One of the major hurdles that Kubernetes faces is secret management. So you think of the sensitive data that your app relies on, like API keys, database passwords, certificates. Securely storing this in Kubernetes is tough. Imagine a scenario where a developer accidentally commits a database password to a GitHub repository. This can lead to a major data breach, exposing the sensitive customer information. This is a real-world risk that highlights the importance of proper secret management. Another security challenge posed by Kubernetes is the intercommunication between these microservices, as I mentioned earlier. So securing this service-to-service communication is another challenge in microservice-heavy Kubernetes. So Kubernetes constantly interacts, so we need to encrypt the traffic between these services using authenticated communication to prevent unauthorized access. So you can consider a financial application where the payment service communicates with the user service. Without proper security, an attacker could intercept these communications, potentially stealing credit card information or manipulating transactions. The dynamic and ephemeral nature of Kubernetes adds complexities. Containers are spun up and down, making them consistently insecure. And it also makes consistent security and vulnerability tracking difficult because you can't persist those security measures that you've put in place. So you can imagine a scenario where vulnerability is discovered in an older container image that's no longer actively used, but still present in some deployment. Tracking down and patching all instances of that image can be a real challenge in a dynamic environment. Finally, compliance and audit requirements are crucial. They're essential. Many industries have strict data handling regulations. And Kubernetes deployment must be auditable and compliant. For example, you have an healthcare application handling patient data. This application must comply with HIPAA regulations. Demonstrating and maintaining this compliance in a dynamic Kubernetes environment can be a significant undertaking. So all these challenges highlight why understanding Kubernetes security is crucial. It's the first step in building a secure and resilient environment. Now let's explore how HashiCorp Vault and Consul can address these issues. So we've explored the challenges. Let's talk about the solutions, HashiCorp Vault and Consul. Each individual tool is powerful, but together they work more powerfully to provide a comprehensive approach to securing your Kubernetes deployments. On the left, you have HashiCorp Vault. Vault is your centralized secret management solution. Think of it as your secure vault for all sensitive data. Another way I would like to explain Vault is you can think about it like a password manager. Well, rather than being used by consumers, it's used by developers or applications. You can call them password managers for applications. So it's a secure vault for all sensitive data. It offers features like centralized secret storage, dynamic secret management, and encryption as a service. Instead of coding secrets or storing them in insecure, your applications can retrieve them on demand from Vault. On the right, we have HashiCorp Consul. Consul provides a service mesh for secure communication, along with service discovery and network automation. It helps you manage the complex network interactions within your Kubernetes cluster, ensuring that services can easily discover each other and communicate securely. So how do they work together? How do they provide security collaboratively? Vault secures your secret, and Consul helps your application securely access those secrets and communicate with each other. They form a powerful combination that addresses many of these security challenges we've discussed earlier. In the next slides, we'll take a closer look at each of these tools individually. Let's begin with HashiCorp Vault. Let's talk about Vault secret engines. They are the core components that allow Vault to manage different types of secrets securely. Remember, I mentioned that you can think of Vault as the password managers, but for password managers for application. And beyond password managers, it stores much more than passwords, certificates, public keys. So Vault supports various secret engines like key values for storing arbitrary secrets. So you want to store or save the port of your database or the name of your database containers. Or you want to store public key infrastructure, PKIs, for managing certificates. Or you want to store database credentials as well. So imagine a large e-commerce company that uses multi-cloud services, say Azure, Google Cloud, AWS, and on-prem. They store API keys of their payment gateway in a key vault secret engine. They use PKI engine to issue SSL certificates for their websites. and they leverage AWS secret engines to generate temporary IAM roles for their DevOps team to access AWS resources. This centralization reduces the risk of hard coding secrets in code or configuration files. So how does this work exactly? So the simple example, the quick workflow is that the developer requests access to a payment gateway API key via the Vault API or CLI. Vault authenticates the developer, maybe using LDAP or token, and checks their permission. Do they have using RBAC, role-based access control, to check that if they have permissions. If they're authorized, Vault retrieves the key from the key vault, from the key value engine, and delivers it securely, ensuring the secret is not exposed in logs or transit. For PKI, Vault generates a certificate signed by certificate authority, valid for a short period, reducing certificate management overhead. For AWS, Vault dynamically generates IAM credentials with specific permissions, which expires after use. All of this enhancing security. Another feature of Vault is dynamic generation. So you consider an healthcare provider managing database for patient records. Instead of reusing single database username and passwords, the application requests temporary credentials from Vault. These credentials are valid for, say, 15 minutes, then automatically rotates that credential, ensuring that even if they are leaked, they become useless after expiration. So Vault dynamic secret generation is a game changer for security, unlike static secrets that stay the same and risk exposure. In the event that you notice a leak in credentials, you could just rotate. You pretty much have nothing to worry about if you have dynamic secrets set up, because the credentials that are generated are short-lived. So all of this minimizes the window of opportunity for misuse or leakage. Another feature of Vault is encryption as a service. So Vault offers encryption as a service, which simplifies secure data handling. Instead of managing encryption keys yourself, Vault provides a transit secret engine to encrypt and decrypt data on behalf of application, ensuring keys are never exposed to the application or user. And this is ideal for sensitive data like PII or financial records. So for a fintech solution, they could use Vault to encrypt customer credit card numbers before storing them in the database. The application sends plain text data to Vault, which encrypts it. Vault encrypts it using key managed by Vault. Then it returns the ciphertext. So the decryption also works the same way, only that Vault holds the key that is used for decryption, thereby reducing the risk for key exposure. So even if a developer, a system admin, or an attacker gets access to the database, all they'll have is encrypted data. Another feature of Vault is access control via policies. So this is a critical feature because policies define who can access what secrets, under what conditions, using a flexible role-based access model. This ensures granular control, preventing unauthorized access while simplifying management. So a DevOps team needs access to production, that's production database credentials, but only for read operations. While the security team needs full admin access to audit logs, Vault policies can be written to restrict DevOps to read-only access and grant security team full permissions, all enforced dynamically. We also have audit logging. So Vault's audit logging provides transparency and accountability because it's the central base for secret access. You want to know, okay, who used this key to access what? So every action reading a secret, generating credentials, and accessing encryption key is logged securely. These logs can be sent to external systems for monitoring, helping detect misuse or breaches. So say you have an online education platform, they could use Vault Audit Log to track who accessed students' data secrets. When an unusual access pattern is detected, maybe a single user accessing thousands of records, the security team reviews the log, identifies the source, and investigates potential insider threats. So this is an image that shows how Kubernetes port authenticates to HashiCorp Vault to securely access secrets using Vault Kubernetes auth method. Let me break this down step by step. On the left, you see Kubelet, which is like the manager of Kubernetes nodes, running commands or managing prods. It sends a JWT token, a special data ticket, downward to Kubernetes pod. The pod is highlighted in blue. There you see it containing the service account and namespace. And you see a sidecar, which is an helper program that works alongside the pod to handle Vault communication. The JWT token travels from the pod to Vault, showing the token goes through Vault authentication, K8 row process, auth K8 row process, which checks the pod identity. Vault verifies the token by connecting to the cluster API. The API confirms the pod's service account and permission. If everything checks out, pod applies a policy granting the pod access to specific secrets based on its role. The pod sidecar then uses this policy to fetch secrets securely, like API keys or password, without exposing them. So all of this provides a secure handshake. The pod proves who it is with a ticket. Vault checks with Kubernetes, and the pod gets safe access to secrets. All of this is perfect for keeping things secure in a containerized environment like Kubernetes. Next, let's discuss Consul. So Consul is a service mesh with mutual TLS or MTLS. This feature provides communication between services by ensuring both parties authenticate each other using TLS certificates. Now, it's like a digital handshake where both the client and the server verify each other's identity, preventing unauthorized access and man-in-the-middle attacks. Next is Consul's service discovery. Service discovery and health checks. So this enables services to find and communicate with each other dynamically. Services register with Consul. Consul tracks their health using periodic checks like pings and like pinging the service and checking HTTP endpoints. If a service fails, Consul automatically removes it from the pool, ensuring reliable traffic routing. So say an e-commerce giant or an online retailer with thousands of microservices handling inventory, payments, and shipping. They use Consul. They can use Consul for service discovery so that the payment service can locate available inventory services. If an inventory service goes down, Consul's health checks detects, reroute traffic to healthy instances without downtime. Next up is network automation and segmentation. This allows you to define and enforce network policies dynamically. You can segment traffic between services, restricting communication based on intent, which enhances security and simplifies operations. Consul integrates with tools like firewall and SDN to automate enforcement. For an healthcare provider, they could use Consul to segment network traffic so that only the patient record service can communicate with billing service while blocking access from less trusted services like maybe marketing, analytics. So this prevents accidental or malicious data exposures across their hybrid cloud environment. Consul integrates with Kubernetes with ease, and this brings service mesh and discovery capabilities to Kubernetes clusters. It works seamlessly with Kubernetes native features like pods and services to provide secure automated service communications in containerized environment. So this is especially useful for organizations adopting Kubernetes at scale. So a software company that runs Kubernetes cluster for their CI/CD pipeline, they could integrate Consul to manage service-to-service communications between deployment pods using mutual TLS for security and service discovery for load balancing. When a new pod spins up, Consul automatically registers it and handles traffic routing, reducing manual configuration. So I've mentioned this term mutual TLS repeatedly. Mutual TLS is, again, mutual transport layer security. It's a security protocol that ensures two parties, like computers to services, verify each other's identity before communicating. It's like a double check where both sides show ID to prove they are trustworthy using digital certificates. This prevents unauthorized access and encrypts their conversations to keep it private. So we've discussed Vault independently and we've discussed Consul independently. Collaboratively, how do they work to secure Kubernetes? First, let's start with Vault integration via Vault Agent Injector. So this feature automatically injects secrets like API keys, passwords, or tokens directly into Kubernetes pods at runtime, eliminating the need for hard-coded or manually changing secrets. It is secure, seamless, and ideal for dynamic environments like Kubernetes. So say that same e-commerce platform we discussed earlier, say they are running on Kubernetes, they could use Vault Agent Injector to inject payment gateway API keys into their checkout service pods. When a new pod spins up, Vault automatically provides the secrets to the pod, ensuring that it can process transactions without exposing sensitive data in configuration logs. Next is Vault Kubernetes auth method. So this authenticates Kubernetes pods to Vault. This method uses Kubernetes secure account to prove a pod's identity, ensuring only authorized pods can access Vault secrets. It's a critical piece for zero trust security in containerized environments like that of Kubernetes. So say a financial service company uses Kubernetes pods to handle customer transactions. The pod handling those customer transactions authenticates to Vault using this method. The inventory management pod uses its service account token to request database credentials, ensuring only trusted pods can access sensitive financial data, reducing the risk of breach. Finally, we have dynamic secrets, where we generate short-lived credentials for database and cloud providers and more. So Vault generates secrets. Vault's dynamic secret feature generates short-lived credentials on demand to resources like databases, cloud providers, or APIs. In Kubernetes, this integrates seamlessly to provide temporary secure access, reducing the risk of credential leakage or reuse. You can consider, say, an healthcare platform. The analytics pod requests database credentials from Vault to query patient records. So these credentials can be mapped or set to expire after 15 minutes, ensuring that even if a pod is compromised, the credentials become useless, quickly enhancing security. Now let's shift to Consul integration with Kubernetes. Starting with Consul Connect, this feature enables mutual TLS, like I explained earlier, to provide service-to-service communication with Kubernetes, ensuring encrypted and authenticated traffic between pods. Like I mentioned earlier, it's like that digital handshake where both services verify each other. each other's identity. Another feature of Consul is that helps ground the security in Kubernetes is the Consul service mesh. But this manages and orchestrates service communication in Kubernetes, providing routing, load balancing, and security. It builds on Consul Connect, which is the mutual TLS, to create a robust, scalable mesh of microservices, simplifying complex interactions between pods at scale. Then, lastly, we have Consul Helm chart. This simplifies deploying Consul on Kubernetes. Helm itself is a package manager for Kubernetes that provides a pre-configured chart to install Consul's agents, servers, and proxies, making it easy to set up a service mesh and discovery in your cluster. So you could use Consul Helm chart to deploy Consul on clients' Kubernetes cluster or your own Kubernetes cluster. Say you're running a DevOps consultancy agency. For a client running a CI/CD pipeline, they could quickly set up Consul for service discovery and mutual TLS, reducing setup time and ensuring consistency across hybrid environments. Integrating Vault and Consul with Kubernetes supercharges your containerized environment, combining secure secret management and robust service communication. Whether you are securing credentials, encrypting traffic, or managing microservices, the integration simplifies operations and enhances security for platforms like hybrid platforms or from low-scale environment to robust environment. So let's talk about the lessons learned from real-world implementations and best practices for scaling. For Vault, you want to use high availability mode with multiple replicas and regular security rotations. Like I've explained earlier, in the event of a security breach, because secrets are short-lived, whatever secrets an attacker gets hands on is rendered useless quickly. So using Vault Rotate, as recommended by Vault's production best practices, Vault's high availability mode is it uses multiple replicas. You can think of them as backup copies of Vault servers, spread across nodes to ensure that system stays up even if one fails. This is paired with regular secret rotation using Vault Rotate command, which refreshes encryption keys and secrets periodically to minimize security risks. So say a financial company uses or is running Vault on Kubernetes, they can deploy Vault in high availability mode with, say, 5 replicas across different availability zones. During a routine audit, they can use Vault Rotate to rotate their master keys every 90 days. It could be shorter depending on how much security you are looking to have. So this can prevent long-term exposure if a key is compromised. When one replica fails due to server outage, the other takes over and seamlessly ensures uninterrupted access to secrets. For Consul, we can scale proxies horizontally and monitor them with, say, Prometheus integration as outlined by Consul's production practices, best practices. So horizontal scaling means adding more proxy instances, like sidecar proxies used in Consul Connect to handle increased traffic, ensuring performance doesn't degrade. Prometheus integrates with Consul to collect metrics, helping you monitor health, latency, and error in real time. So a video streaming platform, they could use Consul service mesh with sidecar proxies for mutual TLS secured communication between microservices. Due to a surge in, say, viewers during a live event, they can horizontally scale their proxies by adding more instances across Kubernetes pods. Using Prometheus, they can monitor proxy performance, spotting latency spikes, and scaling proactively to maintain smooth video deliveries. Finally, a key lesson is to start with, say, 3 Vault nodes or 3 Consul servers for resilience, ensuring scalability in production. Now, this setup provides redundancy. If one node or server fails, the other maintain operations. It's a best practice to build a foundation that can scale as your workload grows, balancing cost and reliability. So these lessons from real-world implementations highlight how Vault and Consul can scale securely and reliably in production by following these best practices using high availability modes, rotating secrets, scaling proxies, and starting with resilient node counts. You can build a robust infrastructure for your application, whether you're handling financial transactions, streaming videos, or processing e-commerce traffic. Now let's explore how the common pitfalls to avoid. The first on the list is incorrectly.
Dami, sorry to interrupt you, my friend. We are a bit over. May we ask you to wrap it up shortly, please?
Okay, yeah. Okay, we'll do that. Do have 1-2 slides to go.
Okay, thank you.
Great, thank you. So, the common pitfalls to avoid are incorrectly setting up the Vault agent injector. Now, this can lead to exposed secrets. The Vault agent injector automatically injects secrets into Kubernetes pods, but if misconfigured, say when with wrong permissions, annotation on network policies, this secret might be exposed in logs, environment variables, or pod specs, violating security best practices. So this issue is detailed in HashiCorp's troubleshoot Vault in Kubernetes documentation if you'd like to read more on that. Another pitfall is misconfigured console intentions. So this can block legitimate traffic, risking service disruption. So console intentions define network policies for service-to-service communication. But if you miswrite that, say with overly restrictive or incorrect rules, legitimate traffic gets blocked, causing outage. So this is well documented in HashiCorp's documentation if you want to read more on that. Finally, we have oversized sidecars, specifically Vault agent sidecars and console proxies. So they can strain Kubernetes nodes, impacting performance. Sidecar runs alongside pods to handle secret service mesh tasks. But if these resource requests, if their resource requests, CPU, memory are too high or not optimized, they can overwhelm node capacity, slowing down or crashing these pods. It is noted again in HashiCorp's documentation if you'd like to read more on that. Finally, we have strategies for achieving compliance without compromising agility. So let's discuss enabling Vault audit logs using Vault audit enable file command. So this strategy ensures every action in Vault, reading a secret, generating credentials, or updating policies is logged securely for traceability. These logs are critical for meeting compliance standards like PCI DSS, which ensures detailed tracking of sensitive data access. It helps maintain agility by rotating logs, automated logging without slowing down operations. Next, using console mutual TLS and intentions for zero trust networking ensures secure authenticated service communication, meeting compliance needs like HIPAA, GDPR. Mutual TLS verifies both parties in communications with intentions, while intentions define strict network policies to block unauthorized traffic. Lastly, or finally, automating the secret lifecycle. That is creation, rotation, and revocation. In Vault maintenance, in Vault, everything is maintained with agility while ensuring compliance. So this approach recommended by Vault's HashiCorp's Vault documentation covers identity-based secret management, uses policies and automation to manage secrets dynamically, reducing manual efforts and meeting standards like NIST or PCI DSS by minimizing exposure risks. So these strategies from real-world implementations show how Vault and Consul can achieve compliance without compromising agility in Kubernetes by enabling audit logs, using zero trust networking and automating secrets. You can meet standards like PCI DSS or IPA while keeping your operations fast and flexible. While you're processing payments, managing healthcare data, or scaling e-commerce traffic, you can ensure that your environment is secure. So the key takeaways from here is Vault centralizes and automates secret management, enabling hard-coded credentials, and it supports dynamic secrets. So no hard coding secrets, like API keys, password directly in code or configs, because it's risky. And again, because it's easily exposed, say in version control or logs, Vault solves this by storing secrets securely in central repository, automating its distribution and offering dynamic secrets that expire and rotate automatically. Next, Consul secures service communication with mutual TLS and traffic control, ensuring zero trust networking. It verifies both parties get ID verifications to be sure that, hey, you are who you say you are. This zero trust model is critical for secure microservices. Finally, Vault and Consul together create a robust framework to protect secrets data, ensure secure communication, and meet compliance. It's ideal for DevOps engineers, security practitioners, and platform architects. Vault handles secret management. Consul handles secure communications between services, forming a powerful duo for modern Kubernetes-based infrastructure. The combination supports agility for automating processes while meeting strict standards like PCI DSS, EPA, and GDPR. So whether you're protecting financial data, streaming media again, or healthcare records, this framework is your key to success. So thank you for joining the session. I will hang out in the comment section, the chat section, to take questions.